All right, from the beautiful studios of Way Happy, this is Mr. Meyer, and we are continuing on with example 3. So let's go ahead and see where we're at here in this example. Now, the last part of this step was after we had finished up this beautiful integral. Part 2 said, hey, do you think there's a way we could do this almost like using our calculator by doing a definite integral? In other words, one that has numbers up on top, so no plus c. And that's where the accumulation part comes in. So remember, the thing about accumulation is what you have now is what you start with plus everything you've accumulated since then. And in math or in calculus, the way we can do that is I can say f of 2 is what I had, we had f of 0, plus everything we've accumulated since then. And what we've accumulated is going from 0 to 2, a bunch of 2x squareds minus 2. That's what we've accumulated. So there it is. There it is. What I have now, f of 2, is equal to what I started with, plus everything I've accumulated since then. And now we can go ahead and solve this problem. So f of 0 we know is 5. And the integral of 0 to 2, well, let's go up a power and divide. So 2/3 x cubed minus 2x. And then that needs to be evaluated from 0 to 2. And so 5 plus, now let's plug it in, 2/3 is going to be 2 times 8 over 3 minus 2 times 2 is 4. And that looks like 5 plus 16/3 minus 4. And since I've done this problem already yesterday, notice we have a 5 and a negative 4. We can just kind of rearrange that and we can get 16/3 minus 1, or sorry, plus 1. And 16/3 plus 1 is 19/3, and holy smokes, we get the same answer. So that brings us to this beautiful part here that says what our equation was, right? And we've kind of created it ourselves. So what you have is what you started with plus what you've accumulated since then, and f prime is just the rate at which f is growing, right? Remember, f prime is the derivative, so it's the rate at which the function is growing. So let's see what we got here. In this example, using your calculator, find the following, but be sure you set up your integral part. All right, so if I'm going to find the following using a calculator, that's not such a spooky thing. I'm going to say f of 3 is equal to, now what did we have? We had f of 2. So it's f of 2 plus what we've accumulated from 2 to 3 of 4 sine squared 2x dx. And there's my integral setup for that one. And now I can put it in my calculator. That's math. Nope. Oh, sorry. I forgot to put in the f of 2. Negative 2. So make sure you use a negative sign. Plus math 9. That is 2 to 3 of 4. Oh, and I hit sign, so there's something important there about what mode I'm in. You know what? And it's going to get squared, so I'm going to put in a parenthesis here. And then go sine of 2x. Then I'm going to get out of that parenthesis, I hope. And then I can go to the second. And then that should close the parenthesis. There we go. And dx. So that got a little yucky. Might be better to do sine x 2x times sine x 2x just so I don't mess up. And it says it is approximately equal to 0.76. Oh, I missed the last decimal. 0.763. And there you have your answer, right? So again, could do the same thing on the next one. F of 5 is equal to f of 2 plus the rate 2 to 5 of 4 sine squared 2x dx. And that on the calculator giving me 4.038. And then I could sit up. You can even do an accumulation backwards, right? I could even go backwards because it does accumulate that way. F of negative 2 is equal to f of 2 plus the integral from 2 to negative 2. So that should give me, if it's below, it'll give me positive. If it's above, it'll give me negative. 4 sine squared 2x dx. So again, just go back to my calculator. second enter if you wonder how to type all that stuff in, but now you got to go left a ton and get to there and then type in -2 and then hit enter, and it gives me -9.011. -9.011. And so there is, oops, approximately equal to, there are all my answers that I got. Now the last part says, all right, now that you've had some fun, can you make an equation using for f of x? So f of any number. Well, notice what's always happened, right? The f of 3, this matched that, and this matched that. F of 5, this matched that, and this matched that. F of -2, this matched that, and this matched that. So keep that logic going. F of x is equal to what? Well, it's equal to where you started, f of 2, plus the integral from 2 to x of, now I don't know if I want to use the same variable here, because it's got to be anti-derived and stuff like that. So I might change it to t, like 4 sine squared 2t dt, just so I don't have a confusion with where my x's are going. And there's my integral equation set up. All right, last but not least, this set looks like it's going to be the same. Calculator permitted, we got g prime, which is our growth of our y variable. We got when x is 2, y is -5. And so let's go ahead and set these bad boys up again. So g2 is equal to what you started with, g2, plus the accumulation from 2 to 2 of e sine of x dx. Now that's a little silly, right? Because what's the accumulation of 2 to 2? Isn't that going to be nothing? Nothing's accumulated? Well, let's make sure. So what I'm going to do is I'm going to say, all right, g2 was -pi, so it's -pi plus math 9, the accumulation from 2 to 2 of e. You know what, on that last problem, I never checked my calculator's mode, so I really hope it was right. Sine of x, and if you guys got a different answer, you probably then know why. Because I did not check my mode. All right, e sine of x, let's check mode real quick. Oh, thank goodness. And let's hit enter. And it says it's -3.14159, which makes sense because it's pi, right? Because there was no accumulation there at all. All right, what about the next one? Let's try g of pi. All right, g of pi is going to be the -pi plus the accumulation from 2 to pi. Oh, notice I didn't put g of 2 this time. I got lazy or more clever. I don't know which one you want to call it. E of sine x dx. So now I'm going to come back over here and I'm just going to hit second enter because that's quick, and I'm going to change that top number to a pi. Second pi and hit enter, and I get -1.169, -1.169. And last but not least, how about g of 0? How do you set that up? You remember, you get a point for the setup. You get, I think, 2 points for the setup when you do this. So g of 0 is equal to, when we go back the old way, g of 2, they'll give you a point for that, plus the integral setup, they'll have a point for that. So from 2 to 0 of e to the sine x dx. And you'll get 2 points for that, and then you'll get a point for your final answer. And so all I have to do is go to 0, and I am golden. Notice the only thing I'm changing is the accumulation, and I get -7.378. That's it. Stay happy, and I'll see you tomorrow.